All right, ladies and gentlemen. So here is the final drawing conclusion from data, the skateboard example. We're going to complete the conclusion organizer, and then we're going to write a conclusion over here. You're going to copy these down as your notes that you can then refer back to later when you're writing your own conclusion from the elastic band data. Okay, so every investigation starts with a question. What is the motion of the skateboard on the sidewalk? So you are looking at your graph of the motion of the skateboard on the sidewalk, and you see that your skateboard is moving away from where it started at a constant speed over time. So it starts down here at around 0, it ends up 9 meters away. It does that at a constant speed. So my claim, when I write my claim, is that the skateboard moves away from its start at a constant speed. So that is my claim. I need to have 3 pieces of evidence to support that. In IPC, the 3 pieces of evidence are pretty much always going to be the same. The first piece of evidence is the trend. So when we look at the data, we see that the trend is up to the right, positive. The trend is increasing over time. So reason number 1 that I know this is that the trend is increasing in a line over time. Evidence number 2. Evidence number 2 is always going to be referring to the data. The easiest way to refer to the data is to look at what you used as your slope calculation points. So basically, at 1 second, the skateboard was 1.25 meters away, and at 8 seconds, the skateboard was 7.5 meters away. Actually, we can just use numbers. At 1 second, the board is 1.25 meters away. Is it 1.25 meters? And at 8 seconds, it's at 7.5 meters. At 8 seconds, it's at 7.5 meters. So first the trend, then the data. The third is always the slope. And there's 2 parts to the slope, okay? The first part to the slope is whether it is positive or negative. The second part to the slope is the meaning of the units. The meaning with the units. So clearly, the slope is positive, right? Moving up was a positive sign, slope is positive. The slope of the line is positive. 0.89 meters per second. With the units, what does that mean? Basically what that means is every second that goes by, so here's 1 second, here's 2 seconds. Every second that goes by, the skateboard goes another 0.89 meters. And then when another second goes by, the skateboard goes another 0.89 meters. And then when another second goes by, the skateboard goes another 0.89 meters, right? That's what's happening. That's what the units mean. Every second that goes by, the skateboard goes 0.89 meters. So, the board moves 0.89 meters every second. And that is the meaning of the slope. All right, so what we're going to do now is we're going to turn that into a little paragraph, okay? And I'm going to color code it. The first part of your paragraph is always going to be your claim, right? And that's going to be yellow for me. So what is my claim? The claim is that the skateboard moves away from the start at a constant speed. So that is my claim from here. The second part is the evidence, which I'm going to color code blue. I know this because, go back to your evidence, the trend is increasing in a line over time. The trend of the data is increasing over time in a line. And that is piece of evidence number one. Piece of evidence number two, the data. This is shown by the fact that the board was at 1.25 meters, 1.25 meters at 1 second, but moved to 7.5 meters at 8 seconds. 7.5 meters at 8 seconds. And that is the data. Then you have the slope. And the slope has two parts to it. So you've got whether it's positive or negative, and then you have the meaning with the units. So the slope is 0.89 meters per second, which is positive. So that's the first part of that. This means that the board moves 0.89 meters each second. And that's the second part. And that is a complete conclusion.